Welcome to the Real Python Podcast. This is episode 162. What advice can you extract from the Zen of Python? How can these 19 guiding principles help you write more idiomatic Python? This week on the show, Christopher Trudeau is here, bringing another batch of PyCoders Weekly articles and projects. Christopher shares a Real Python article by Bartosz Zaczyński titled, What's the Zen of Python? We talk about how to access the Zen within Python and the poem's origin. We also discuss how different sections provide contradictory advice for what makes good Python code. We cover a recent post by previous guest Matt Harrison about using Python and Pandas for finance. Matt's article covers methods in the Pandas library for aggregation, resampling, and rolling averages. We cover several other articles and projects from the Python community, including a news update, solving a Legend of Zelda puzzle with Python, avoiding simply providing advice, displaying better stack traces, and creating files with fake data. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Christopher, welcome back.
Hey there.
So we got a nice round of news this week, a whole bunch of items, right?
Yeah, lots of bits and pieces here. So first off, we've got a bit which is a little stale. It happened since our last podcast went out, but it was a while back. There were new point releases for Python 3.7, 3.8, 3.9, and 3.10, 3.10 and 3.11, excuse me. And that same announcement spoke of 3.12 beta 2. But since then, 3.12 beta 2 has already been replaced with 3.12 beta 3. So lots of progress there on the release front. Next little bit has to do with PyPI. Their ongoing journey to implement two-factor authentication continues. A while back, they turned on 2FA for high-volume accounts, and although they turned it on, they were still allowing password-only authentication to help ease the transition.
Yeah.
So that transition is done now. So if you've got 2FA turned on for your PyPI account, you don't have a choice. You have to use 2FA. So that's part of their ongoing move towards getting better security going on there. After that, the faster CPython plan for Python 3.13 has been released. We've talked about most of the features on the roadmap before, including things like PEP 669, 554. We're not going to get into it. But if you want to see all the proposed changes in one place, there's a GitHub link if you want to take a look at that. Okay, and on top of that, PyPI, the alternative interpreter, has released a new version. That's 7.3.12. This version supports Python 2.7. They still support that. 3.9 and 3.10. And the last little bit is some news from Read the Docs. That's the open source hosting site for documentation. A few years back, they added the ability to configure your documentation settings through a YAML file called .readthedocs.yaml. The format of this file has been updated to version 2, and they're phasing out the use of version 1. So if your docs don't currently have a config file or they use the old version, you're going to need to upgrade. You'll get email about it. The final cutover date is September 25th, and there are some blackout windows in the meantime as they test the new systems.
Yeah. We've talked about this a few times about the versions of YAML, so that's probably going to be a nice change. That's the new standard, right?
The primary piece here I have found is essentially they've been deprecating parts of the dashboard, things that you used to do through the dashboard. They started adding new features and they didn't stick them in the dashboard. So you needed to use this config to get at certain kinds of features on Read the Docs.
Okay.
And so essentially, like my old projects still use the dashboard. My newer projects have one of these YAML files. And so the note I got from them was basically like, these are things you haven't touched in a while. Not that's the way it was phrased, but that was the consequence. So yeah,
right.
Like, okay, right. And one last little thing, not quite news, but this morning I read that Twitch has updated its content classification rating system. So, Mr. Bailey, as we intend to keep this podcast family friendly, please no kissing or licking of the microphone. That's now considered adult content.
Oh.
There goes our plan for the podcast.
Yeah. I guess I'll keep those cameras off. I have one little note I wanted to add because we've talked about PyCon US 2023 a few times and talked about PyCascades 2023 a few times. I may have mentioned the videos being up already for PyCascades, but just to make sure people are aware, yeah, the videos are up on YouTube for both of those conferences now, and I'll include links that you can go and check them out. As we dive into topics this week, you have a real Python one you wanted to start with.
Yeah, my first article is What's the Zen of Python, which is by frequent Real Python contributor Bartosz Zaczyński. If you're new to Python, you might not have come across the Zen before. It's sort of an Easter egg containing development philosophy, and you can see it by opening up a REPL and typing import this. It's kind of referred to as a poem, but that's kind of liberal if you ask me. But for want of a better phrase, the poem was written by Tim Peters, a long-standing CPython core dev. And if you've ever heard of Tim Sort, well, yeah, it's that Tim. So I won't read the whole thing, but it starts out with beautiful is better than ugly, explicit is better than implicit, simple is better than complex, and complex is better than complicated. And like with all good advice, there are situations where you just shouldn't follow it, and places where it comes close to contradicting itself. And the article introduces you to the Zen and then kind of breaks down the different parts and talks about how strict you should be about it and how to interpret some of the text. If you're wondering why this is coming up now, even though this has been around for a long time, there was a talk recently at PyCascades by Chris Neugebauer about the limitations of the Zen, where he talks about things like decorators and type hints and whether they actually follow the guidelines. Quick preview of that argument is decorators intentionally hide what they do away, and it could be argued they violate the explicit is better than implicit.
Yeah.
And I might even take that one further and say, when you have a function that wraps and returns a function that wraps and returns a function, quite possibly using a decorator itself to write your decorator, you're probably bumping into that ugly thing as well. You were at that conference. Did you see the talk?
Yeah, it was really good. I enjoyed it, and there's a lot of humor in there. And I think the Zen of Python has kind of its own weird, sort of snarky humor in it, hiding too. It was a good way to kind of point out a lot of these ideas. So if you enjoy this article, definitely check out the talk.
Yeah, in fact, one of the things the article talks about is the original posting of this was not inside of the code. It was on one of the mailing lists.
Oh.
And when Tim posted it, he said, these are the 20 Python, started to write the word feces and then backed it up and called it theses. So there's some toilet humor even embedded in the history of this. So although it's not bad advice, the tongue is planted in cheek as we go along.
Yeah.
Yeah, the article goes to sort of dive deeply on some of the lines of the Zen. In fact, it does a bunch of stuff where reasonable people might differ. One of the examples Bartosz uses is the formula for a sinusoid, complete with using the Greek letters familiar to those who use the formula. He breaks this down, adding and changing the complexity to show different aspects of the Zen. To me, this is almost an unintentional example of the ugly clause, though, because if I'm maintaining your code and you're expecting me to use characters that aren't on my keyboard, which aren't inside of strings, you're going to find me using stronger words than ugly.
Yeah. Where do I find that key combo?
Exactly. If I need to do a Unicode lookup to find the symbol and use Alt to type it in, I'm not going to be a happy camper. Anyhow, so the article wraps up with a section on the humor, which we were just talking about, including some of the history of where it came from. And there's a bunch of inside jokes buried inside. So if you're interested in a bit of Python history, want to get all philosophical about your coding approach, or just want to learn the Zen well enough to use it as a weapon in a flame war, this article can help you do all that.
Enjoy.
Enjoy.
Yeah. So my first one is from previous guest Matt Harrison, and the title pretty much sums the whole thing up. It's titled Python for Finance, Pandas Resample, Groupby, and Rolling. Just a note, it's a blog post that's on the ponder.io website, and Ponder is a kind of interesting tool that it can sort of sit on top of a database to run pandas sort of inside your database. Like that's how they explain it, in your database. Just as a note, Matt is an advisor to Ponder. The crux of this thing is that it's going to teach you some really kind of handy pandas features and a couple other kind of tricks and tips along the way. The specific examples, again, are shown running on the Ponder platform, but you could access the data yourself. It uses an interesting data set. It's the FDIC Bank Find suite, which I was not familiar with, but some data that you could kind of play around with. If you're not familiar with it, the FDIC, the Federal Deposit Insurance Corporation, has bank failure data and provides valuable insights into the underlying causes of these failures and helps to develop effective risk management and regulatory compliance strategies. It kind of harkened back to something I used to do. I used to be kind of involved in risk management for a loan portion of a bank. And so that was very interesting to kind of see some of this data. But the data that he grabbed from this overall suite of information that's on the site is bank failure data from 1934 to 2023. And he had about 4,000 entries. He takes you through the real common data grooming kind of stuff that you might do, like renaming columns, fixing date formats so that they can be used a little bit more appropriately. He shares a whole data dictionary sort of explaining the abbreviations and the codes that are used by the FDIC and something like resolution types. How did they resolve this? And of course, that probably's changed since the 30s. He starts out by using the count feature to figure out how many failures per year. He uses the .dt accessor to access them. And then he shows a couple different plots, defaults to showing kind of a very noisy bar graph where it's very hard to read every single year being printed at the bottom. And so he shows the steps to make it a little more readable, make it as a line plot. And then he shares a really nice feature that's a little bit hidden in Pandas. It doesn't show when you look at, say, the doc strings. If you're using Jupyter and you're inside there and you like, oh, hey, I'm going to hit tab to be able to see what's happening. It's a feature called offset aliases. For dates, you can use an offset alias of yearly, quarterly, monthly, weekly. So by using the resample feature, he can kind of convert the time series data into several time series data with different time intervals. So you can look at what was happening monthly with an overarching, like what was happening yearly. So he kind of shows that, creates an aggregated version to kind of overlay in his graph. It's kind of neat, because the monthly can be a little noisy, and with the yearly, you kind of get a good idea of like the overall picture of what was happening. And then he goes on demonstrating Groupby and creating plots with that, and then shows how to do a feature that I haven't ever needed to use, but something that I could, again, see in financial data that would be very handy, which is a 12-month rolling average. And it's just the .rolling method and shows how to work that. And overall, it's just a really good demonstration of how to tackle one of these kind of problems. He doesn't give you direct links to the data, but he does give you a link to the website that you could find the data to grab to go through some of these examples on your own. It's a neat demonstration, and Matt's definitely an expert on the Pandas stuff. And I would suggest if you're wanting to learn a little bit more, I'll include a link to our previous conversation that we had on the podcast. I have a question for you, Chris. There are three big sort of peaks in this data that you can kind of see. There's one in the 30s, which would be the Great Depression and the banks then. And then there's one in the 80s and the beginning of the 90s. And then there's, of course, the housing crisis, more recent, 2007, 2008. Which do you think is the tallest?
Oh, I wouldn't even know how to guess.
It's the saving and loans crisis that happened
in the
80s and early 90s. Yeah. It's crazy how many savings and loans failed in that time period. And then, of course, they were insured through the FDIC. So it seems like, I remember hearing about it, but it just wasn't a focus of my life in the 80s, to think about. And it didn't really affect me as much as the 2007, 2008 stuff. So
I have vague memories of Black Monday, and my father explaining he worked for IBM. And so his only stock investment was the shares that he got as part of working for IBM.
Yeah.
And they crashed massively. And I remember him talking about how severe the drop is. Of course, as a kid, your first thing is like, will that affect us? And he's like, yeah, it might take me a couple more years to retire, but that was sort of the thing. But yeah, it was. I do remember it being catastrophic.
Yeah.
But yeah, I just pulled up the graph now that you're mentioning it. It's not even close.
Yeah, it's crazy.
Yeah.
But I mean, the difference is the consolidation that happened after that. So the monetary values were maybe similar with the 2007, 2008. And it's just, regulations may be good, guys. Whatever.
Yes. Well,
anyhow.
At risk of praising Canada, our banking system survived that quite gracefully.
Okay.
So there might be an argument for having some rules. Yes. So
yeah, whatever. All right. Well, tell us about something fun.
All right. So my next one is an article by Gaz J, and it's called Python and the Legend of Zelda. So long before Zelda was crying, there was an Oracle of Ages game on the Game Boy. And near the end of the game, do I have to say spoiler alert for something that's over 20 years old? There is a puzzle with a room full of colored tiles, and the tiles are laid out in a 13 by 9 grid. And when you step on one of them, they switch colors. So if you step on it twice, it goes from red to blue and back to red. And your goal is to turn all the blue ones to red. And there are 4 stones in the room, so you can't just walk, along in a linear path. So this puzzle seems to have driven Gaz a little crazy. And he's got like some screenshots in the article of like, look how close I am. I should have been able to do it. I'm only 1 tile away, but if I go here, that's not going to work. And if I go there, and he's a programmer. So how do programmers do this? Well, he figured he'd write a program to figure out how to solve the problem.
Yeah.
And so the article writes you through the Python script that he wrote. It emulates the puzzle. He isn't actually connecting to the Game Boy. He's just writing a program that has the puzzle in it. And then he's doing a brute force search algorithm to try and find the right answer. He runs the script for quite some time. I think he said it was like up 7 or 8 hours. And I won't spoil it, but there is a bit of a twist. And the article shows how you actually solve it. And then talks briefly about, if you were writing your own games, how you might be able to design these kinds of puzzles. So it's a neat little article, and from one old man to the other, do you remember the days when you were frustrated as all get out and couldn't just look the answer up on the internet?
Yeah, you'd go down to the magazine stand or something.
The magazines, that's right. All games made extra revenue by selling you cheat hints on paper.
Yeah, exactly.
I'm old.
Yeah, no. I still have books for some Bethesda games, so... the books for Oblivion and Skyrim. So I guess that's not, well, Oblivion's maybe almost 20 years. Oh, ouch. Never mind. We'll just talk about Starfield when it finally arrives here. So
there you go.
Okay. So my next one is, this one's kind of hard to describe. The blog is called Bytecode. Spelled BITE, so take a bite out of code. And it's a Substack, sort of mailing list. I don't know what to call that. It's basically like a blogging platform / mailing list. And the author is listed as, quote, nobody has time for Python. And the author's Twitter handle is the same, so I don't know much about this person, but they don't have time for Python. The piece that I'm referencing is linked to another one that's from even earlier, but both of them are from a little bit earlier this spring. And the first one I'm going to mention, the sort of follow-up is called Why Not Tell People to Simply Use Pyenv, Poetry, or Anaconda. It has a little subtitle of, you keep using that word. I don't think it means what you think it means, which is a good reference there. And it's a follow-up on one titled Relieving Your Python Packaging Pain. And its subtitle is 60% of the time, it works every time. He states in that one, in the new one, I shared what I've witnessed to be the most reliable way to avoid many Python packaging problems for a large number of users. And by packaging problems, it's actually kind of less sharing packages and sharing programs with other people, and more, I would almost argue, simply, installing Python and using packages and being effective as a end user, even a beginning end user, which is kind of the goal of the piece is like, hey, let's hit this large number of users, sort of Pareto style, like say, hey, we can hit 80% of the people with this advice. First off, one of the things that many teachers try to do and real Python tries to do is to avoid ever saying simply, because it ain't. It ain't always simple, and something can go weird. And with saying that, you're kind of making a bit of an enemy out of the person who said, but you said it was simple and it was, and simply just do this thing. And so it's not endearing to people as far as like helping them get along on their path. So the original article listed the steps to take without really justifying them. And I'll mention them. The list of specialty tools that he mentions to kind of avoid using is maybe avoid using Homebrew for installation of Python. I kind of have to agree with that one. Homebrew is a really wonderful tool, and it's great that it exists, but it's a real odd duck as far as like how it installs on your machine. It's very specific for Macintosh stuff. There is kind of a thing on Windows called Chocolatey that, I don't know. It's kind of the same thing where you're kind of getting yourself into deep water there. And another specialty tool that he kind of says maybe you should avoid using is Pyenv for managing lots of Python installs. He also mentions maybe don't use Anaconda if you're not doing data science stuff day to day, and Poetry unless you need it and you're comfortable using it. None of these are simple tools, which I agree. They're all very specific tools, kind of very much hitting a niche. And we've written articles on many of them on Real Python, but not necessarily to say, hey, this is the only way to go. If you're starting with the basics and getting going, the original article advised, hey, number one, don't install the latest major version of Python. And reasoning there is, depending on what you're trying to do, libraries may not be up to date for it. You're also on the bleeding edge of everything as far as features. And so there's, you can kind of be a little bit safer and maybe holding back a little bit, especially it always kind of depends on what you're trying to do. I'll have a note on that later about with the project I'm going to talk about this week. The second one is to use only python.org for installing on Windows and Mac, or use official repositories on Linux. I agree with that. I've had the best luck with that. Python.org is a really great source for getting that stuff, and it's just kind of a solid solution generally. Never installing or running anything outside of a virtual environment. We talk about it all the time. Almost every single video course that we put out there, we try to suggest that it's a good idea that you should do things inside a virtual environment. If you can, limit yourself to the basics of pip and Pyenv for creating virtual environments. If you run a command such as Python pip install, make sure that you use the -m flag. And that, again, is a really great way to make sure that you're targeting this specific install. And when you're creating a virtual environment, be explicit about which Python that you use. So I agree that, that's going to hit about 80% of the people that are out there. And so the community the Python community is super diverse. We talk about that all the time on the show. And when we talked about packaging earlier, of actually packaging things up and distributing it and all the narrow cases that are there. But you really need to target for the masses when you're providing advice, as opposed to, specific small group. And that's what I think a little odd, in that he's writing this Substack article, which is probably going to be read by those more expert people. It's not necessarily somebody finding this out on the internet. So I think that's why he got a lot of feedback that was, well, you should do it this way. And of course, the internet and so forth. But he ended up writing the second piece, and I just love it. It's a total rant piece. It's a good old rant post. And I'm guessing he received some feedback and he's like, I need to address this. And for me, it was a really fun thing to read, mostly probably because I agree with most of it. And I think that his reasoning is pretty solid, and he's backing up what he's saying with it. again, most of the tools mentioned that he says to avoid were intended, for specific use cases, and those edges. And again, it depends on your use, right? But the edge cases can be really sharp and can cut the intended user, and they will spend much more time finding bandages and trying to heal than actually using Python. And I've run into that myself. People come and say, oh, I'm going to use this or I'm going to do that. And then they're busy playing with a tool instead of doing Python. I'll mention an example of that. Pyenv, for example, it doesn't always install a full version of Python. I guess you could say, quote unquote, broken. And there isn't a whole lot of warning about that. It's missing portions of what would be included in the standard library. Maybe the reasoning is it's a little smaller or whatever, but that's something that if you then suddenly want to use tkinter and it's not there, it's like, okay, well, what did I do? Why is this broken? And then how do I fix it without completely changing things? Pyenv also makes a lot of decisions about your paths, and you may or may not know what that it's doing there. It doesn't work on Windows. Half of the Python audience, maybe more, is on Windows. And the advice of saying, well, just install the WSL, the subsystem for Linux. Now you have a potential novice.
Yeah, here's your answer. Go install another operating system.
Yeah. Someone who is
as a client of your operating system, that'll solve your problem.
Yeah, someone who is told, "Hey, you should use Python instead of Excel."
Yeah,
and now they got to learn a new OS and a terminal paradigm.
And while you're at it, use Emacs.
Yeah, because it's better. And Anaconda is kind of a similar thing. Like I experienced that in my first days in an office using Python. It was a quote unquote Anaconda shop. This is what we're going to use. And all the articles I would see would say, pip install this, pip install that. Well, it's not great to mix using Conda for their virtual environments and then using pip. It has its own package management stuff. It's like, stay in that realm, do it all there, and it's fine. But if you start mixing things and you start crossing things over, bad stuff will fall. And that's hard. It's hard to learn until you've already kind of messed up your environment. It's not that it will solve all your problems, but it will make a big difference. And they go through each little piece of advice and goes through them. And I won't spoil it all because it was a very good read. I really enjoyed it a lot. And I appreciated kind of what they were putting in there. And so I'm looking forward to reading more from Nobody Has Time for Python and bytecode. I think it's a nice resource. And it was fun reading this. And yeah, just, typical, hey, advice for beginners. These are a good set of 6 standards, I think, that will help most people get by. Edge cases be edge cases.
Well, and I think it's important advice, not just for beginners, right? Like,
yeah.
This is important advice for those of us who aren't beginners to remember what we're telling beginners.
Yeah. That's the other
right?
thing. Yeah.
Like, okay, what is gravity? Well, if I'm answering the question to a 5-year-old, we're going to talk about Newton and apples. And we're not going to talk about bends in space-time, right? Like, you got to
exactly.
you have to understand your audience.
Here, sit down and watch this movie from Nolan.
That's right. You comment about the article starts out with this, don't say simply, easy is another one of those words that you're supposed to avoid. I had a prof who I think it was almost a vocal tick. He used the word obvious a lot. And the problem was the course was quantum mechanics. There's nothing obvious in that ever. And every time it came up, like, you could just hear the entire class sort of groan. It's like, yeah. Here's a third-rate differential equation, and we go from here to another level. And obviously, no.
After 30 years, it's now obvious to him.
Yeah, you lost me 3 chalkboards ago. There's nothing obvious about this at all.
Don't you love those like university chalkboards that like they can rotate up and down, and move around? It's like, I was looking at that one.
Yes.
Anyway. I think that gets us to our discussion this week. Is that right? Yeah.
Yep. And we're heading into this started out from a discussion on Hacker News called "Is Parallel Programming Hard? And if so, what can you do about it?" And we're looping in something that is kind of on the same topic, which is an opinion piece That's everybody who's posted about this has modified his title slightly differently. On PyCoders, I called it Async IO Why I Hate It. And it's by Charles Leifer, who's the creator of PyORM. So the question being posed really is sort of two parts, right? So is parallel programming hard? And the second part is, what can you do about it?
Can I pause you briefly? It's referencing a book by Paul E. McKinney, and it's a free book, PDF, that you can download. It's 662 pages as a PDF, but it's basically about doing parallel programming in C. It's most recent revision of it. So I'll include a link for it. But I thought it's interesting because it's the whole book's, a premise is, this question.
And it's a very deep dive. It's not, in fact, one of the parts of the thread it actually talks about it's closer to sort of like being a reference book rather than something that you'd read from front to back. Yeah.
Okay.
And that the first part of that question, is parallel programming is hard? If it was just that, we'd say yes, and there you go, we'd be done. It'd be a short conversation.
Yeah.
The second part's kind of where it gets interesting. Now, the internet being the internet and Hacker News, sometimes you get nice stuff and sometimes you get the internet. The first good chunk of this article, almost half of it, is really just a drawn out conversation about vocabulary, where everyone assumes that the way they were taught was the one true way and everyone else is wrong. And this gets into a deep semantic difference between the words parallel and concurrent when you talk about parallel and concurrent programming. And depending on how you were introduced to the space, these are either synonyms or subtly different.
Yeah.
I'm not particularly interested in arguing over nouns. Personally, in my head, they're synonyms, but in all fairness, that could be because I'm misremembering the textbook definitions that I haven't read in 20 years.
Obviously.
So if you're going to look at the discussion, you might want to sort of scroll past the first little bit. Although there is some interest in where kind of the semantics of it comes from and where some of the confusion uses. And this is always one of the things, if you're talking to somebody about a topic that's new to you, understanding how they're using words and how it might be different than how you're using words can be rather revealing.
Yeah.
But the two main concepts to me that kind of drive these kinds of programs, whether you want to call them parallel and concurrent, I'm not going to get into that argument, is the idea of IO bound work and CPU bound work. So the first is the stuff that spends all of its time waiting on input or output, like, say, data coming in over a network. And the second is whatever pegs your CPU, and the next thing getting done is waiting on the CPU becoming available. And how you approach these two different problems is different. So threads work for IO bound because even if you have a single CPU, one thread can be put asleep while it's waiting on some IO, and you switch off to another thread. So let's say you're writing a program that reads content from a bunch of different websites. The processing that you do on that content will likely be several orders of magnitude faster than the time it takes to fetch the content. So you can go off and have many threads, each one fetches something, and then you wake up when it's been fetched and you do your processing. By contrast, in the CPU bound case, this doesn't work. So if I'm trying to compute primes, I'm not waiting on IO, I'm just doing math in the CPU. The only thing I can do in this case is add more CPUs. So independent of these two concepts is a separate idea, sometimes called trivially parallel or embarrassingly parallel work. And this is a problem where the division of labor between the pieces is obvious and there's little to no interaction between the different parts. So that example I was using with downloading content, that's a good example because what one thread is doing isn't dependent on what another thread is doing. They just grab stuff and go. And in the CPU case, let's say you're doing an analysis on a really large image, and you can break the image down into pieces and operate on the individual pieces. Once you've got the image broken down, each CPU can work on one of those chunks, and the more CPUs you throw at the problem, the faster it can go. Now, the challenge is very few problems are embarrassingly parallel.
Yeah.
And even those that are, you end up in a part of the time is embarrassingly parallel, but not all of it. So let's go back to that image example. At some point in time, you're going to have to do some work to break the image into pieces. That itself might not be parallelizable. And then after you've done the analysis on the image, you're probably going to have to take all that data and gather it together. And that also probably can't be done very parallelizable. And so this kind of fan out, fan in pattern is really, really common in parallel computing. So there's chunks that you can get speed up by throwing more threads or more CPU at something, and then there's chunks that you don't. And then where the answer to the original question, it turns into, is it hard? Yeah, it's hard, is once you start having to deal with these situations communicating with each other. So there's a concept called deadlock, where you've got two items blocked on the same thing waiting for each other, and race conditions, where the order of computation changes the result, meaning your code is no longer deterministic. And this is where it gets brutal. This is where the hardness comes in.
Yeah.
So, I did my grad work in this, and the joke I often make is the only thing I really learned is try not to do it. And in fact, one of the comments in the discussion thread is, you'd be amazed how much you can accomplish these days on a single thread with the right optimizations. And essentially, that's just the argument of, don't do this unless you really, really need to.
Right. It's that whole premature optimization thing that people like, this is the new hotness and I should go do this. And it's like, well, you could be doing other things too, instead of just optimizing for this, it always is interesting to me.
Yeah, and it also connects to sort of the, how time bound are you, right? So,
yeah,
if you're working on petabytes, you're going to have to do something along these lines.
Yeah, sure.
If you're not, and your processor takes 1 minute and 30 seconds instead of 1 minute and 29, you might just want to wait the extra second rather than garner the overhead, right?
Right.
And the complication and how all this kind of comes back to the async IO article is there are a whole bunch of different ways of doing threads and how threads behave, even just within Python, let alone with going out into other places. So async IO is built in. And Charles, the primary premise of his article is basically, I hate it, don't use it. And he talks about using things like threads and G-event instead. And his argument is the async IO is cooperative threading, which basically means the thread doesn't give up and get passed off to another thread until it says, yes, I'm willing to be given up. And so if you haven't written your code in a well-behaved fashion, the other threads will just sit there and starve. So there's some real trickiness that can get involved in this. And like I said, you want to be careful diving into this particular pool.
Yeah. I wonder sometimes about kind of the motivation on writing some of these things, and we talked about the beginning of the whole thread thing of just battling about just semantics of, word choices and so forth. But I would have to argue that I've talked to, a handful of people already on the show about using async IO, and it's working great for them, and they're comfortable with it. So many of the new frameworks are kind of doing a lot of that work for you, in some ways.
Part of his argument is, and you see this in other languages as well, is if you are using the language features to support asynchronous mechanisms, it has to be all the way down the stack.
Yeah, okay.
And so what'll happen is, if your library is built on a library that's built on a library, you might get down to the bottom layer and it doesn't do asynchronous. And then all of a sudden what's happened is your asynchronous call is getting converted into a synchronous call and you get none of the benefit. And this is why you start seeing like asynchronous specific libraries. For example, if you're doing requests, the requests library is synchronous. And so if you want to do something similar, there's AHTTP, which is an asynchronous version that does similar kinds of things. And so you're not just into I can slap this new keyword in here and I will get this change. You're now I have to figure out what libraries to use. And most of the synchronous libraries, if you're careful about them, can be handled using generic threading. So if you're into the coroutine space and you're using libraries that work, and it's easier now because more of the libraries are in that space, but you can get threading going and not run into any of those problems. And that was part of his argument. I still personally find it easier to wrap my head around threads than coroutines. But again, it's hard to judge whether that's the right answer for somebody else, because I was writing threads in C 30 years ago. So I've already got that mental model. So I'm not sure how much of that is, my bias and how much of that is, actual complications from coroutines.
You definitely do need to make sure that the whole stack of libraries and things you're importing, follow, because you're right.
Yeah, and we're seeing it everywhere, right? Like independent of even async IO, you look at like the Django library versus something like Fast API.
Yeah.
Fast API from the beginning was thought about as an asynchronous thing, but of course it's a much younger library. And so over the last 3 or 4 versions, Django has slowly been introducing these things. And so I think they're just getting to the level where the database is properly asynchronous. So if you go back 2 versions, you could have like asynchronous views, but you couldn't hit the database yet. And as soon as you went to the database, you were back into synchronous mode. So there's a shift in the larger libraries that have been out for a while that are sort of heading in this direction. But depending on the pace of adoption, your mileage is going to vary.
Yeah. Just kind of on this topic, kind of following on with the discussion there, you had done a video course a little ways back about speeding up Python with concurrency. In fact, that's its title, Speed Up Python with Concurrency. Yeah, it's like over an hour here. It's a pretty good chunk of stuff, but you get not only into explaining computers and latency and concurrency, but then dive into threads, race conditions, async IO, and then also some of the multi-processing stuff in there. Anything else you want to mention about the video course? Because I'll probably link it this week.
Yeah, good deep dive on sort of the IO versus CPU bound and the fact that in Python you have to choose which library you're going to use in order to solve those problems, and when you can take advantage of this, when you actually get speed up, when you don't get speed up. So yeah, it's a good intro to the topic if I do say so myself.
Yeah, and includes all the sample code. Kind of play around in here and try some of the stuff out. It's a nice resource. So cool. And it'll probably be our spotlight for this week. This week, I want to shine a spotlight on another Real Python video course. It covers the topic discussed this week and is an exploration of multiple forms of concurrency in Python. The video course is titled Speed Up Python with Concurrency. It's based on a Real Python tutorial by previous guest Jim Anderson, and the video course is presented by my co-host, Christopher Trudeau. In the course, you'll learn the following: how IO-bound programs are affected by latency, which concurrent programming patterns to use, how race conditions complicate your concurrent program, what are the differences between IO-bound and CPU-bound workloads, what are differences between the Python concurrency libraries, and how to write code that uses the threading, async IO, and multi-processing libraries with code examples. I think it's a worthy investment of your time to learn about the concurrency methods available in modern Python and the various ways it could speed up your programs. Like most of the video courses on Real Python, the course is broken into easily consumable sections. Each lesson includes a transcript, including closed captions, and you'll have access to code samples for the techniques shown. Check out the video course. You can find a link in the show notes, or you can find it using the search tool on realpython.com. I think that brings us into projects, and I was going to go first here. My project it's spelled PYMG. I'm not sure how to pronounce it. Its subtitle is A Better Display for Stack Traces. The project's by Mohammed. The username is Mim Sayedi on GitHub. And then there's another contributor to the project, Amir Malakian. And it's a CLI tool that can interpret your Python files by the Python interpreter it displaying the error message in a more readable and easier to understand way if the exception occurs. It's one of those kind of prettifying tools that we've talked about before that helps you just kind of be able to picture what's happening and so forth. One note, and I'm kind of mentioned this from my article earlier, this does require Python 3.11. This is one of those things that is probably taking advantage of some of the new features to get into here. It uses the PyCompile module and the Python interpreter to make sure that the syntax of the Python file is correct. And this will be done with the help of the subprocess module, and the output gets captured. So it uses a feature that's kind of interesting. It is a sort of important feature called a mirror file. And a mirror file it imitates what's happening in the source. And in order to capture the data of the exception that occurred, a piece of code has to be added to your source. So you import sys, and then from pymg, it imports a method called display error message. And it basically takes over this exception hook. The sys.accept hook is now going to be display error message. And that piece of code replaces that accept hook, uses its own customized function, and then when an exception occurs, the accept hook function of this module is still executed, but then it's captured in that mirror file. And anyway, they do a nice little quick example, and I was just impressed by how the output looks. Again, if you're maybe wanting to teach somebody about stack traces, and it could be a really handy tool for something like that. They use an example of doing like a 0 division error, and it'll say, okay, trace 1 is happened in this part of the module, and then it then shares in trace.-2 where the actual division's happening, and then what's being returned. It also shows like the locals, so the values that were used in that, and it's really kind of a neat little command line stack trace tool. So I was impressed with it. All right, so what project did you have this week?
So this is a little interesting testing toolkit called Faker File by Artur Barskayan. I don't know if you've ever used a data generation tool when you're testing. There's one called Faker as well.
Mm-hmm.
And they're basically like little mini databases that give you like a schema and then you spit out a bunch of data that you can use in your test cases. So this is like that, but for files. So if your program takes one or more files as input, this tool will generate them as part of your test suite. Supports about a dozen different file types, including a variety of images, MP3, PDF, PowerPoint, Excel, all the open Office docs, EPUB. So it's a nice little collection.
Wow.
And it also handles a bunch of different storage mechanisms. So you can write to like a file or to like S3 or other places as well. So it has both a command line interface and a programming interface. So if you just need like a quick one-off, the command line will spit it out. And if you're doing something more complicated, you can write a script. I didn't have time to play with it yet, but it even integrates with Django. So if you've got like an ORM that has a file field, you can poke it at it and say, I'm going to generate this kind of file for that and put it into your testing things. So I did run into a couple rough spots. It comes in a collection of packages. So there's like the base package and then common and others. And so, for example, if you're not using OpenOffice, you don't have to install that sub package. I went to use the CLI and it requires a certain subset and it didn't work because I did pip install. So if you want to use the command line, you want to make sure you've got the right package there. Now, after running into this, I filed a bug and Artur almost immediately replied back, pointing out it was in the documentation. So my bad for not seeing that. And we had a quick conversation and now he's putting in a try except wrapped in a print message like 2 hours later. So there was a quick fix in here.
Nice.
And now it'll at least tell you what went wrong rather than just saying, I can't find this. So always nice to see a maintainer be quick on their feet with this stuff. The other little complication I ran into is probably a Mac specific thing. The generated files go to temp, and on Mac, that's this weird buried subdirectory that can be a little hard to find.
Yeah, that's an odd place.
And so inside the script, the name was relative, so I couldn't figure out where it was putting it. But the command line tool does actually show the full path. And then once I knew where to look, it was like, oh, hey, look, there are all my other files that I generated. So, but like I said, I think that's a Mac specific thing. And so neither of those things are really problematic once you figure them out. And having the ability to feed test files to your software is pretty cool. In fact, one of the examples I was playing with was a zip file, which generates like the internal. So you can say this is a zip file with text files and an Excel file inside of it. And in fact, you can like have a zip file with a nested zip or whatever your use case is. So this is definitely worth checking out if you're playing around with the kind of software that is pulling files in as input and you want to include this as part of your testing.
Yeah, it looks really handy. One thing I want to mention that it uses that sort of square bracket notation for, how you want to pip install it. One of the choices is faker-file square brackets all. Sometimes that is odd depending on your terminal. It may not like square brackets. So sometimes you need to put that whole string after, pip install, just, put a pair of quotes around it, and it usually works much better if it, has to have that square bracket stuff. So if you're getting some kind of strange error. But yeah, there's examples of like square brackets common, or you can go into the specific if you don't want to install too much, like I guess XLSX or docx or whatever it is you're trying to get the fake stuff for. And there's a common one, which I wonder how many things it has.
It was most of it. I think it just didn't include some of the open office stuff and some of the things that require a lot of other dependencies.
Okay.
And if I remember correctly, if you used the common, that was what you needed for the CLI, was like the base one.
So. Okay, cool. This looks fun. always need fake data.
Yeah, exactly. That's right.
It's very painful to create on your own. All right. Well, thanks again for bringing all these articles and projects this week, Christopher.
Always fun.
All right. Talk to you soon.
Bye.
I want to thank Christopher Trudeau for coming on the show again this week. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.